Namaste student. Today we're going to see some application of Euclid division lemma. Here we have so many important questions like show that any positive integer can be written in the form of 3m, 3m plus 1 or 3m plus 2, or show that any positive integer can be written as 4m, that means 4m plus 2 or 4m plus 1 or 4m plus 3. So here you can see this type of presentation, that means 3m, you can see 3m plus 1, 3m plus 2. This is for one question. Second question, show that any positive integer can be written in the form 4m, 4m plus 1, 4m plus 2, 4m plus 3. Third question, show that any positive integer can be written in the form 5m, 5m plus 1, 5m plus 2, 5m plus 3, 5m plus 4. The fourth one, show that any positive integer can be written as 6m, 6m plus 1, 6m plus 2, 6m plus 3, 6m plus 4, and the last 6m plus 5. And what are these m? M is integer. Here m represent integer. Okay, so now what are we going to see? That this means what? That we're going to see today. Like if it any positive integer, they are saying that any positive integer means it start with a 1. That means they are talking about the natural number. So here the natural number start with a 1, 2, 3, 4. That means this number can represent in this form, or this number can be represented out of this 4, any one of them. Or if you go for this, so is it limited to this? No, it may extend like 7m for 8m, like that it continue, but in exam we get only this out of 4. Okay, and once you know this all 4, how to represent, what are the basic concept, then you can go for the more than that also, no problem. So here we're going to see what does it mean. That's 3m, 3m plus 1 and 3m plus 2 means what? That means if you take 1, then you can write 1 as 3 into 0 plus 1. And can you see this is 0? 0 means one integer. So 3, you can represent here 3m plus 1. This is the representation of 1. If we go for the 2, you can write here 3 into 0 plus 2. That means 3m plus 2. If we go for 3, you can write here 3 into 0 plus, not 0, 1 plus 0. That means 3m. This is the representation of 3. If you go for the 4, you can see that 3 into 1 plus 1, that is 3m plus 1. For 5, 3 into 1 plus 2, that is 3m plus 2, where m is an integer. 6, 3 into 2, which represents 3m. For 7, you can write here 3 into 2 plus 1, that is 3m plus 1. And if we go for 8, 3 into 2 plus 2, that is 3m plus 2, and the 9, 3 into 3, and it will continue so on. So same concept if we go for the 4m, that means 1 can represent like 4 into 0 plus 1. For 2, 4 into 0 plus 2. This is what? This is the representation of 4m plus 1. You can see that this number is 4m plus 1. And for this 2, 4m plus 2, you can see here 4m plus 2. Now for 3, if we go, that is 4 into 0 plus 3, that is 4m plus 3. For 4, 4 into 1, that is 4m. So if we'll repeat the number, not repeat that, if we'll continue with the number, you can see that 4 into 1 plus 1. And if we'll go for the 6, that is 4 into 1 plus 2. For 7, 4 into 1 plus 3, and for 8 again 4 into 2. So what you can see that 4m plus 1, 4m plus 2, 4m plus 3, and 4m. So for 4 you can see that this, out of this any 4 you can represent the whole natural number. And if we go for the 5, that means for 5 we will choose, so any natural number can be represented as 5m, 5m plus 1, 5m plus 2, 5m plus 3, 5m plus 4. And if we go for the 6, also you can represent 6m, there would be 6 number 1 2 3 4 5 6, that means 6 representation would be there. And if we continue the way we have done for your 3, done for the 4. And in exam they're asking us to prove that any positive integer can be represented either this or this or this or that. So we have a video for this, so you can go through that. Thank you.